Hey everyone, and welcome. Today we're diving into a really special kind of Python function. It's one that seems to have a memory. They're called generators, and trust me, once you get how they work, you'll see how they can totally change the game when you're dealing with huge amounts of data.
So let me just start with this question. A normal function, right? It runs from the top, hits the bottom, and it's done. But what if it had a pause button? Imagine you could get just one value from it, hit pause, go do something else, and then come back and tell it to pick up right where it left off. Well, that's the powerful idea we're going to explore today.
So here's our game plan. First, we'll unpack what makes a generator a function that remembers. Then, we'll get into how it actually pauses instead of just stopping. We'll put the all-important yield keyword head-to-head with return. After that, we'll discover why being lazy is actually a generator's superpower. And to wrap it all up, we're going to code something that seems impossible, a sequence that goes on forever.
All right, let's get into it. What exactly is this function that can remember things?
Okay, so here's the official definition. A Python generator is a function that cooks up a sequence of values, but it does it on the fly. Instead of building a massive list in memory and handing it all to you at once, it produces values one at a time. And it does this using a very special keyword, yield. And when you call it, you don't get a value back right away. You get this thing called a generator object. Using one is kind of like a four-step dance. First, you call the function just like any other. But remember, you don't get a value back. You get that special generator object. And get this, the function's code hasn't even started running yet. Then you ask that object for a value, maybe with a for loop or the next function. Only then does the function finally wake up, run until it hits a yield, and hands you a value.
All right, let's do a quick knowledge check on that key point. The very first time you call a generator function, what do you actually get back? Is it A, the generator object itself? B, the first value it's going to make? C, a whole list of all the values? Or D, just the none object?
If you said A, a generator object, you are spot on. And this is so crucial to understand. At this point, the function is just sitting there completely dormant. It's basically waiting for you to say, okay, I'm ready now, give me the first one. That is a huge difference from how regular functions operate.
So how does the function just wait like that? Well, it all comes down to this really simple but powerful idea. It's pausing, not stopping.
Just take a look at this code. It's about as simple as a generator can get. We define a function called counter. Notice there's no return statement. Instead, we have three yield statements: yield 1, yield 2, and yield 3. Now, let's see it in action. We call countering, and we save that generator object in a variable called gen. The first time we call nextGen, the function runs up to that first yield, hands us the number 1, and then just freezes. The second time we call next, it wakes up right where it was, runs to the second yield, and gives us 2. And it does this one more time to give us the number 3. It's amazing. And that's the whole secret right there. Yield sends a value back, but it keeps the function alive. Python freezes its entire state, all the local variables, the exact line of code it's on, and it just waits. The next time you ask for a value, it thaws everything out and continues right from that spot. That is the memory we've been talking about.
Okay, so this whole magic trick really depends on one single essential keyword. What is it that tells Python, hey, this isn't just a regular function, this is one of those special generator things? Is it generate, next, return, or yield?
The answer is D, yield. That's the one. It's the keyword that completely transforms a regular function into a value-producing factory, just waiting for your orders.
This brings us to a really important comparison. Let's put yield in the ring with its more famous cousin, return, so we can see exactly how different they are.
This table really makes it clear, doesn't it? A return is final. It's like a mic drop. It ends the function, period. But yield just hits the pause button. Return runs once, and it's out. Yield can be resumed over and over again. This makes return perfect for giving you a final answer. But yield is designed to produce a stream of values, which makes it incredibly lightweight on memory.
And that whole memory thing is so important, it deserves its own section. Let's talk about the real superpower of generators, the power of laziness. Let me paint you a picture. Imagine you have a massive log file. We're talking terabytes of data with billions and billions of lines. Now, if you write a normal function to read that file and return a list of all the lines, well, good luck with that. You're trying to cram an entire skyscraper of data into your computer's RAM, and it is going to crash hard.
The solution is a beautiful strategy called lazy evaluation. This is the whole philosophy behind generators. Instead of doing all the work up front, a generator does basically nothing until you ask it to. It'll read just one line from the file, yield it to you, and then go back to sleep. It only computes or fetches a value at the exact moment you need it.
I mean, the difference in memory usage is just staggering. Look at this. A normal function trying to load everything at once has its memory usage shoot through the roof. That's the bar on the left. A generator, though, its memory footprint is that tiny constant bar on the right because it only ever holds one item in memory at a time. This is why generators are an absolute must for big data.
All right, now for the grand finale. Let's take this power and do something that would be literally impossible with a normal function. We're going to code an infinite sequence. Take a look at this beautiful piece of code. This is a Fibonacci sequence generator. It starts with a equals 0 and b equals 1. Then it enters a while true loop, a loop that never ever ends. Now, in a normal function, a while true loop is a death sentence. It would just freeze your whole program. But because yield pauses the execution, this works perfectly. And look how we can use it. We create our fib generator object. The first time we call next, we get 0. The next time, 1. The next time, 1 again. Then 2, 3, 5, 8. And we can just keep calling next literally forever. We have created an infinite stream of numbers that takes up almost no memory. How cool is that? Okay, so one last question to tie this all together. Back in that Fibonacci generator, what happens to the variables a and b every single time the function yields a value? Are they thrown away? Do they become global variables? Or is their state simply paused and preserved, just waiting for you? And the answer is C, their state is paused and preserved. Those variables a and b are frozen in time until the next call. That is the memory that makes everything we've talked about possible, from the simplest counters to infinite sequences. So we've seen how generators use yield to pause, save massive amounts of memory through lazy evaluation, and even achieve the impossible. So the final question isn't about how they work, it's about what comes next. Now that you know how to build infinite streams of data with just a few lines of code, what will you create?